All right, what's up? Whoever's watching this video, there's one of three of you that I'm talking to. She knows who she is. Anyhow, back to the topic at hand. We are doing a chemistry project, and my group includes myself, William, Illieona, Hallenbeck, Sophia, Alvarran, Gary Messenger, and Keireon, Manning-Mumford. Today, the topic we have chosen to do is solubility, and as you can see, we have some nice little experiments lined up to show you just exactly some reactions and how it works. Some things are insoluble, some things are soluble. But before we really get into the experiments, let me explain some basic definitions. So solubility is the ability of a substance to dissolve in water. Some substances can form homogeneous solutions. Now, the thing doing the dissolving is called the solvent, and the thing being dissolved inside the solvent, which could be any type of liquid or component, is a solute. All right, and now we're going to show you some stuff about saturation, so I'm going to hand it off to my other team members.
Okay, we're going to start off with different types of solutions. You have unsaturated, saturated, and supersaturated. Right here I have a glass of water and some salt, and I'll put a little bit of salt in here. There, and I'm going to mix that up. Now, you really can't tell that there's any salt in here whatsoever, and that's an unsaturated solution, which means that a solution in which the solvent is capable of dissolving more solute, which means I can add more salt, which I'm going to do. Okay, now you can see some salt particles floating in there. I don't know, it might be a little dark, but now this is a saturated solution. This is the maximum amount of the solvent being, or the solute being dissolved. Can't add any more unless it becomes supersaturated, which is when you do this and you get the whole mountain of salt. Maybe. Well, if we had a bigger glass, then maybe. I got it.
It's super saturated.
It is super saturated. I was hoping to get a mountain of salt to come. Oh, there we go. There we go. There we go.
That is most definitely super saturated. If that's
And you cannot add any more. Look at this. Can't add any more. Super saturated, you know, you can't add any more to that. And that's all I have. That was a bad idea.
And this is why you should not eat the experiments. And next we have Keireon explaining our first insoluble solution, and obviously he did something stupid.
You're stupid.
Your mother. Who?
Your mother. Huh? The next, here.
So what's happening here, Keireon?
Well, obviously the two substances aren't mixing, because you see you have the water on the bottom and the
And what's that called?
insolubility.
Okay. Okay.
Now you see these two don't mix because you have the oil floating on top of the obviously water. Look at it. Look at it. Look at all these little bubbles just segregating.
Look at Gary poking it like it's silicone.
Gary, no need to segregate it even more. Okay, see that little bubbles floating down.
Oh, that was weird.
Look at this nice, cool little separation right here between the water and the oil at the end of the plate.
Yep, right there, little crescent.
It's a nice little happy Hat Man Hank smiley face.
Yeah. Yeah.
No, it's a chemistry thing.
Yeah.
Are you ignorant?
Oh.
And this is why we have Gary, to do ignorant things that we don't want to do.
Squishy.
Well, Gary, it's oil.
Yeah.
The dingus.
You ding-a-ling. And next we have Illieona explaining our next insoluble solution.
Okay, so this one is insoluble, and you know that it's insoluble because it doesn't dissolve, it creates a reaction. So,
This is vinegar and baking soda, by the way. Look at all those bubbles. Those are threatening bubbles.
Don't eat it, Gary.
Those ain't pretty bubbles.
Those is deadly bubbles.
To add a little oomph to our last experiment, Gary's gonna explode this here water bottle
Where's the top?
by pouring vinegar into the baking soda with the top on, which Sophie is gonna kindly place, I guess. Nope, Gary has it, never mind. I don't know if I should be standing this close to it, but hey, we're unsupervised, so it's okay.
That did not work.
I don't think it's gonna explode.
No, you didn't get the lid on fast enough.
Yeah, no, I didn't. It's not that I didn't put the lid
I
on
really thought
fast
that guy was running away. He's just jogging.
It's not that I didn't put the lid on fast enough. It's that I didn't twist the lid on.
Dang.
Yeah.
Boo.
Boo, Gary!
Lied.
Oh God, Keireon's gonna
work.
die.
No. There's air in there already.
We
It's not
tried.
gonna work.
All right. You want to go on to the next one then?
JK.
Yep.
And this is what a failed experiment looks like.
It's
Here once again is Illieona Hallenbeck explaining our final and most fun experiment.
Okay. This Diet Coke here is an example of a suspension, which is a temporary mixture in which the small, invisible particles will eventually settle, which is different than a colloid, which has large visible particles. Okay.
Oh, okay.
What are you doing, Gary?
What?
You messed it up, man. You're messing up.
What are you doing? What are you doing?
Well, I guess he just showed you that the chemical in the Mentos releases the CO2 from suspension in the Diet Coke.
Oh, you idiot.
Wait.
Group
I don't
shot.
like you.